Hello guys, today in this video I'm going to introduce the nonlinear thermal analysis using WELSIM. I believe most of you guys already heard about nonlinear analysis. Whatever is structure or thermal, it may always have nonlinear conditions. Mm, For the structure, we may have nonlinear material, we have contact or larger deformation, all types of the nonlinear conditions. For the thermal analysis, we usually refers to three types of nonlinearity. One is the nonlinear material, which is a temperature-dependent material, like thermal conductivity is based on the temperature. The second nonlinearity it could be the nonlinear boundary, which is dependent on the temperature. Third type of nonlinearity is the radiation boundary condition, because the radiation is a very high nonlinear boundary condition in the thermal analysis. So this is the three major nonlinearities in the thermal analysis. So today we're going to use the WELSIM to demo how to solve the problem that has a nonlinear material. So the WELSIM already opened on my desktop. So the version I'm using is 1.9. Then let's check the unit first. So let's set the unit to be a kilogram to millimeter. Okay. The temperature unit is going to be Celsius. Okay. Click OK. Then let's create a new project. Then first step, since we need a nonlinear material for the thermal analysis, so we define a new material instead of using the structure steel. So we already create a new material and double click or right click. Just select the edit. We have this pump up the window, make it bigger and easier for us. So for the thermal analysis, we need three properties. One is density, another is isotropic thermal conductivity, and specific heat. Okay. Then usually I need to set the units that I'm very familiar. Okay. Then for the density, give it 4,000. Specific heat, okay, 400. Isotropic thermal conductivity, we're gonna set it a nonlinear conductivity. So I wouldn't directly input here. We gonna input the temperature dependent value on table. Okay, the first temperature is 20, second is 50, third is 100, then 200, 500. Then we define the conductivity value for each temperature. 55 for 200 degree, 56 for 500 degree. So we can see this curve is really high nonlinear curve for the conductivity. So the material is defined. Then let's just close it. We see this material state is green check mark, which means it's well defined. Click the FEM project. Let's change the analysis type to the thermal static state analysis. The geometry, we're gonna input a CAD file. So this is one body analysis. It's kind of a pipeline connect to another one. So then very important step, we need to assign the material to this newly imported geometry. This material ID 11 is the material that we just created. Okay. For the mesh, then we make the element size, maximum element size to be 3 millimeter. And use quadratic high order element and click the meshing. Okay, we have 58,000 nodes and nearly 29,000 elements. Okay, so next step, let's impose initial condition, because in the thermal analysis, it's always recommended to impose the initial condition that defines the ambient temperature. Let's impose the two temperatures to mimic the temperature inside the pipeline. One temperature is here. Let's assume it's 450 degree. Okay, the second temperature boundary we impose here. The inner part of the inner surface of the small pipeline. We give it temperature 100 degree. Okay, that's it. Then we set all these boundary conditions, materials, and note that the material is nonlinear for the conductivity. Let's just click the solve button. Okay. Let's see the Newton solver is working now. It's several. You can see there are 6 iterations here, and the problem is solved. Let's add the temperature and see what it looks like. So this is how it looks like for the final temperature distribution on this body. Okay, this is a very simple and straightforward demo for the nonlinear thermal analysis WELSIM. So if you have any question or comments, please let us know. Thanks for watching. Bye.